All right, I want to get right into it so you guys have enough time to start, maybe finish this homework. We did reflections on Friday. I flip over a line. Now we're going to do what's called a translation, which means I'm going to take a figure and move it up, down, left, and right. Okay, up, down, left, and right. You remember with reflections, I just reviewed here before I went over homework, reflections lowercase r. There's unfortunately 3 ways you could see a translation. All right, 3 different ways to represent a translation. The first way, function notation. Here's what function notation is. It's going to say, all right, you're going to start out with any point, x, y, little arrow that shows that, hey, I'm going to turn it into the following. I'll just make up 2 here. X plus 2, y minus 3. That's called function notation. All right, function notation. It's telling you what happens to the x, add 2 to your x coordinate, subtract 3 to your y. That's great, but I also want you guys to understand what's happening to the point because it's being moved up, down, left, and right. What do you think plus 2 means on the x? Which direction am I moving it? Plus 2 if it's with the x coordinate. X coordinate, where do you think it's moving? Right 2. So this basically is telling you guys, hey, my point is moving right 2. And then what happens, do you think, if I'm subtracting 3 on the y coordinate? Where's it going then? Down 3. So I move my point right 2, down 3. Or, again, you could just simply add 2 to your x and subtract 3 on your y coordinate. That's called function notation, everyone. Function notation. You tell me what's happening to the x and the y. All right, next one, vector notation. You just separate them. Vector notation. You're going to see these. I guess they're inequalities, but they're not for inequality. And then inside, I'm going to have your 2 numbers inside. That tells you what to do to the x and the y. That's vector notation. Still a translation. Right 2, down 3. Right 2, down 3. Still the same thing. And then you might see the following. It doesn't have a name, so I just called it other. You'll see a capital T. Capital T for translation. And then remember Friday we had the subscripts. You'll see subscripts here. 2 numbers tell you what direction to go. All 3 mean the same thing. Right 2, down 3. All 3 of those notations mean the exact same thing. A translation, sliding it up, down, left, and right. All right, take a look. I did a square. I don't know if it's a square or not, but A, B, C, D, and then A prime, B prime, C prime, D prime. I want to know, is this a translation? How can you tell? You every not 2 out of 3, not 2 out of 4, not 1 out of 4, not 3 out of 4. All 4 points get moved the same distance and direction. So what I want you to do right now, from point A to A prime, how many units am I going and what direction? And is that the same for B, C, and D? Check by yourself or within your group right now. Am I moving the same distance and direction to get from A prime, B to B prime, all 4 of those points? Am I moving in the same direction? Are we? Are we moving the same distance and direction? Okay, so yes, this is a translation. How do you know? Moving, same distance and direction for all points. Okay. All points are moving the same distance and direction to get to their image. All right, now I'm going to turn this over to you guys. In words, what is the translation? Up, down, left, and right, and give me the number of units. In words first here. So you describe in words what's happening to A prime, B to B prime in your own words, distance and direction for me. Let's start it off right today. 6, distance and direction.
Up 3. No, up 6, down 3.
Up 6.
Oh, wait.
Down 3. I'm going up and down here, not the elevator, Nate Dog.
Over 6, down 3.
What do you mean over? I could go 2 ways. I'm being difficult for a reason.
Right 6.
Okay, here we go. Right 6 and
Down 3.
down 3. There you go. Now, is it wrong if you flipped them and said down 3, right 6? No, but usually we put the right and left first because it's the x coordinate, up and down second because it's the y. All right, now use a vector notation. Vector notation. All right, so I put it in my vectors. What numbers are going to go in the vector now? That says right 6, down 3. What number should I put in there? 12?
6,
Positive 6, comma, negative 3. All right, nice. Questions? Anything? All right, let's keep grinding. All right, given triangle ABC, let's throw it on a graph. Graph its image. Two, 1. 3, 3. Negative 1, 3. Now there's the pre-image. Now graph its image along this vector, negative 4, 1. Somebody first, before we start, in words, every point's moving where? Give me a direction and distance. You're going to move every point. If I have negative 4, 1 inside the vector, where are they moving? 9, how are they moving? Left 4, up 1. Yep. So everyone take each point, move it left 4, up 1. And then make sure, what are we calling our points now? Prime, right? A prime, B prime, C prime. Whoa! Thanks, bud. Good, thanks. That was easy. Thank you.
Yep.
Graph it and also let me know what the coordinates are. Left 4, up 1. And then let me know what the coordinates are when you're ready here. 7, let's roll. A prime.
negative 2, 2.
B prime.
And negative 1, 4. Which is X.
C prime.
And negative 5.
There you go, Kara. 3 for 3. Anything? Okay, let's go. Let's go. More practice here. You got ABC, another triangle. Let's do this. And then part B, it says, under that translation, now I'm using that other notation, capital T with the subscript 3, -1. Somebody tell me where are the points going? Direction and distance. I'm moving all points where? 6, where? Down in distance. Direction and distance.
Right 3 down 1.
Right 3 down 1. There you go, everyone. Right 3 down 1. Got to be aware of all the different 3 notations for a translation. What do you got for your A prime, B prime, C prime? 3, Spence, when you're ready.
3 1.
3 1. Where'd that come from?
Sorry. 0 3.
Okay, I like that one better for A prime. How about B prime?
-1 -2.
Yeah, come on now, finish.
0 1 1 0.
Killing me. There you go. I'm not going to do part C. We don't need to draw the vector. That's not concerning you. That doesn't. It never comes up again anyway, so why waste time? How are we looking, all right? Because now I'm going to really challenge you. All right, we did a translation. 3 3 went to 6 1. We slide this figure. You guys can figure out up, down, left, and right, and how many units. Using the same rule, find the pre-image of these. All right, so first thing, let's find what the rule is. All right, so from 3 3 to 6 1, and we can write it in any notation we want. I'll just use capital T. Somebody tell me what the rule is. If I went from 3 3 to 6 1, what should be my rule? Up, down, left, right. I'm sorry, left, right, up, down, and how many units? 3 3 to 6 1. What was my rule? 11?
Right 3.
Yep.
Up 2.
Right 3.
Up 2.
You went from 3 to 1, right?
Down 2.
Down 2. So 3 -2. There's my rule. Now, the A and B is where I ended up. What was the pre-image? Where did I start? So here's what I'm looking at. Where did I start? And I went 3 -2 to get to 8 3. Everyone understand the directions before I let you go and think about it. Okay, where did I start? And I went right 3 down 2 to get to 8 3. Same thing for part B, but I ended up at 2 -5. So you guys are going backwards here for me. Where did I end? Where did I start and use that rule? So from this point, the answer, you went right 3 down 2 and got to 8 -3. So think about going backwards. Instead of going right 3, go in the opposite direction. Instead of going down 2, go in the opposite direction. And these are coordinates. We think we're all right? All right, let's check. 5, if I ended up at 8 3, where did I start?
5 1.
Okay, 5. But if you go down 2, you ended up at 1. What y coordinate must I have started at, went down 2, and ended up at 3?
1. Wait. Oh, 5.
5. So 5, 5. Everyone all right? Because guys, think about it this way. Just take 8, 3 and go, instead of right 3, left 3. Go the opposite way to where you started. And then what about the next one? 10, where did I start if I ended up at 2, -5?
0.
Okay, ready? If I start at 0 and go right 3, I end up at 3. Right?
So 5 or
Here you go. If I start at 5 and go right 3, I'm at 8 now. Okay, ready, Iris? I'm going right 3, correct? So go backwards. Go left 3. If I end up at 2 and go left 3, where did I start? -1, right? And if I went down 2, now instead go up 2. What's up 2 from -5? -5. Where this is -5. Up 2 from -5. There we go. All good? Anything? Before we get to probably my top 5, one of my top 5 problems of the year right here. The old marching band. Anybody do band camp? Anybody in the band? Nate Dog, you are? No? And no, we don't have any band camp kids in here this year? None? Wow. Okay. That's fine. I was never one myself. 5th grade baritone, and that's where it ended, everybody. That is where it ended. So, all right, no band camp, so, all right, never mind. We're going from position 1 to position 2. In words, where are you going? Up, down, left, and right, and how many units? And then we're going to put it into function notation. So first, worry about the words, everybody. Going from position 1 to position 2. Give me direction and distance. And whoa, be careful. Anybody notice anything about your X and Y axes? Thank you, Spence. They go by 2. Be careful. They go by 2s. All right, so I'll let you guys figure out how do I get from 1 to 2 in your own words, and then we'll put it into function notation. So up, forward, left, right, back. What are we doing to get to 1 to 2, and how many units is it taking? And then we'll go function notation. All right, in your own words, where are we marching to? Ooh, 2? Where are we marching to, Nate? To get from 1 to 2. First, up, down, left, right.
Left 6.
Left. Now, what did we just talk about, though? You might have counted 6, but
12.
left 12, right? And everyone notice we're not going up or down any. We go left 12, we land right on 2. So that's it. No up or down, just left 12. Ready? Function notation. Look back at the beginning of your notes if you need to. X comma Y goes to, now tell me what's happening. Left 12. Left 12. What am I going to put with the X if I go left 12? 6?
Minus.
So X minus 12. Comma, did I go anywhere with the Y's? Nope. So you have 2 options. You can just write Y, and that's it. Didn't go anywhere. Or if you want to put +0, -0, that's up to you. But we can just leave it Y because we didn't touch it. And last one for the day. Now let's go from 1 to 3 now. 1 to 3, but use a translation vector. My piece of advice, just to help you out, say it in your own words in your head, or write it down in your own words, and then convert it to a translation vector. All right, so go ahead. How many are you going left? There's definitely some up and down here from 1 to 3. So 1 to 3. 2 units, remember every time. All right, somebody in words first. Where are you going here? 9, where are we going?
Left is 1.
And
Down
10? I'm just looking here. Like, when I go here, this is from here to here, and that's not on one of the, this is like halfway in between. So I don't think it would be 10, probably would be what instead? Because it looks like I'm going, ready? 2, 4, 6, 8, but I don't go to 10. 9. So down to, over left 12, down 9. That's what 1 to 3 is. Left 12, down 9. How can you write that in a translation vector then? 3, left 12, down 9. There you go. Negative 12, negative 9. Questions? All right. 5 and 6, the graphs are not optional. If you have to graph 18 and 19, they are. All right. So if you don't want to graph for 18 and 19 only, 18 and 19 only. And then, hey, when you get to 23 and 24, everyone sees the write a rule from blue to green, because it doesn't say in your textbook, but I'm telling you, blue to green. Graph paper's up there like usual if you need it, or use the back of your packet. All right, let's get it done and get out of here.
Yeah.